Welcome back, everyone, to the deep dive. This time, we're going to dig into something really interesting. Vermicomposting.
Vermicomposting.
You got it. Basically, it's how to take everyday waste and turn it into some seriously good fertilizer.
Okay, I'm intrigued. Like kitchen scraps to garden gold kind of thing?
Exactly. And you know what's even cooler? It all comes down to these tiny little helpers called enzymes.
Enzymes. So we're talking about the science behind this.
You bet. You actually sent over a bunch of scientific papers on this, remember?
Oh, right. Yeah, those were fascinating. A lot to unpack there.
Well, that's why you're here. You're like the expert at breaking down this complicated stuff. And by the end of this deep dive, folks will be ready to start their own little vermicomposting operation at home.
Their own. Sounds ambitious. I mean, where do we even begin?
Let's start with the basics.
Okay.
What exactly is vermicomposting, for those who are new to the concept?
Okay, so vermicomposting is kind of like nature's own recycling system, but on fast forward. We're using earthworms, those little composting champs, and a whole bunch of microbes to break down organic waste.
Okay, so it's like composting, but with worms as like the waste-eating superstars.
You could put it that way, but don't forget it's not just the worms. There's this whole microscopic world of bacteria and fungi in there all working together. They're the unsung heroes.
Ah, the microbial crew. And that's where the enzymes come in, the ones you mentioned earlier.
Bingo. Enzymes are like these tiny little tools, these biological catalysts that really speed up the whole breaking down process. Like imagine trying to break down a big pile of leaves. It would take forever. But enzymes, they make it happen much faster.
So they're like, what, the shredders and grinders of the compost world, breaking things down into smaller pieces?
Perfect analogy. And the thing is, there are different types of enzymes, each specializing in breaking down specific types of waste. Like cellulose, which is in plant cell walls, that's really tough to break down. But there's an enzyme, cellulase, that's like a cellulose busting machine.
So it's like having a whole team of specialized demolition experts in there, each tackling a different part of the job.
Exactly. A demolition crew, a waste-eating orchestra, however you want to picture it. It's pretty amazing what's happening at that microscopic level.
Okay, so you've definitely piqued my curiosity about these enzymes.
Yeah.
Can we dive into some specific examples? Like, which ones are the real superstars of vermicomposting, and how do they actually make the fertilizer better?
Oh, absolutely. Let's start with phosphatase. Now, this enzyme is key for breaking down organic phosphorus. It's like unlocking this hidden nutrient that plants need. And what's really interesting is that phosphatase activity actually slows down over time during vermicomposting.
Slows down. Why would that be? You'd think you'd want it to keep going strong, right?
Well, it seems that the system is sort of self-regulating. As more phosphorus becomes available, the system dials back the phosphatase production, keeps things balanced.
Wow, that's pretty clever. Like a built-in control mechanism preventing any nutrient overload. What about nitrogen? That's another big one for plant growth, right?
Right. And that's where urease comes in. It's all about the nitrogen cycle, converting urea, found in many organic wastes, into a form plants can actually use.
So if I add something like cow manure, which is high in nitrogen, to my compost, I'm essentially giving those urease enzymes a feast, right?
Exactly. But you have to be careful. Too much nitrogen can actually create problems for those worms, like too much of a good thing.
Makes sense. It's all about maintaining that balance, that delicate ecosystem within the bin.
You got it. It's kind of like you're a compost conductor, making sure all those enzymes and microbes are playing in harmony.
That's a great way to put it. Okay, so we've got phosphatase and urease. Are there any other enzymes we should know about, other key players in this microbial symphony?
Oh, definitely. There's protease, for example, which is all about breaking down proteins.
Proteins, right? Those are essential building blocks for, well, just about everything, right?
Absolutely. And what's interesting with protease is that some things can actually boost its activity, like magnesium and calcium, while other things, like a substance called EDTA, can actually hinder it.
So it's like you have to be mindful of what you're adding to the mix. You don't want to accidentally sabotage your protein breaking down crew.
Precisely. You've got to think of it like a recipe. The right ingredients, the right conditions, everything plays a role.
Now you're making me hungry. Speaking of ingredients, what about fats? I mean, those inevitably end up in the compost bin, right?
Oh, for sure. And that's where lipase comes in. It's the fat-busting enzyme.
Wow, so they're enzymes for fats too. That's amazing.
Right. And lipases, they have this cool little lid that actually controls their activity. It's like a built-in regulator.
Fascinating. So they're like the carefully controlled demolition crew of the fat world. And speaking of specialized demolition crews, we were talking about chitinase earlier. That one sounds pretty interesting too.
Chitinase, yeah, that one is key for breaking down chitin. It's found in insect exoskeletons and fungal cell walls, so it's a pretty common component of organic waste.
Okay, so it's like the bug and fungi demolition team.
Precisely. And some bacteria actually use chitinase as a defense mechanism against fungi, which is pretty cool. It's like a microbial turf war going on in there.
A turf war in my compost bin. I never thought of it that way. Okay, so we've got chitinase for bugs and fungi. What about all that plant matter? I'm thinking leaves, grass clippings, that sort of stuff.
Ah, yes. That's where cellulase comes back into play. Remember, it's the one that breaks down cellulose, the main component of plant cell walls. And research has shown that certain things, like biochar, can actually enhance its activity.
Biochar, I've heard that's great for soil. So it's like a double win. It helps the composting process and improves the soil in the end.
You got it. It's all about optimizing the system, making it as efficient and productive as possible. And speaking of optimization, there's another important concept to understand when it comes to vermicomposting.
Okay, hit me with it. I'm ready for more compost wisdom.
It's called microbial succession.
Microbial succession. Sounds complicated?
It's not as complicated as it sounds. Basically, it means that the microbial community in your compost bin is constantly changing. It's not a static population. Different types of microbes thrive at different stages of the composting process.
So it's like a microbial dance party, with different groups taking the lead at different times.
I love that analogy. You're exactly right. At the beginning, when you first add your waste, the party is dominated by microbes that love those easy-to-digest materials, like sugars and starches. They're the quick energy microbes, the ones that get the party started.
Okay, so they're like the opening act, getting things warmed up for the main event.
Exactly. And as those readily available compounds get broken down, the party scene changes. Now, the microbes that are specialized in breaking down tougher materials like cellulose and lignin, they move in and take center stage.
So the music changes, the lights dim, and the dance floor gets a bit more intense.
I love it. You're getting the picture. It's this beautifully choreographed sequence with each group of microbes playing their part at the right time, ensuring a complete and efficient breakdown of all that waste.
That's amazing. I never realized there was so much going on in there. It's like a whole ecosystem, constantly evolving.
And that's one of the things that makes vermicomposting so fascinating. It's this dynamic process, constantly adapting and changing. And as those microbial communities shift, so do the types and amounts of enzymes present.
So it's really this intricate web of interactions with the microbes, the enzymes, the environmental conditions all working together. I'm starting to see why they call it black gold. It's like alchemy.
You got it. And the best part is, it's something anyone can do. Even if you don't have a green thumb, you can be a master composter.
Speaking of mastering composting, before we get into the nitty-gritty of how to actually set up a bin,
Yeah.
can we talk about one of the biggest concerns people have? The smell.
Ah, yes. The dreaded compost odor.
Exactly. I think that's what holds a lot of people back. They picture a stinky, fly-infested mess.
I get it. But honestly, with a little care and attention, odors are totally manageable. The key is to avoid adding those really smelly culprits like meat, dairy, and oily foods. Those are the ones that really cause a stink.
Okay, so no meat, no dairy, no oily foods.
Got it.
What about all those fruit and veggie scraps?
Fruit and veggie scraps are fine. Just make sure to bury them under the bedding, out of sight, out of mind, and out of smelling distance.
So proper burial is key. Makes sense. And I'm guessing moisture control is important too, right?
Absolutely. You want the bedding to be moist, but not soaking wet. If it's too wet, it creates the perfect conditions for those smelly anaerobic microbes to thrive.
Okay, so moisture is a balancing act, just like everything else in this composting world. So besides avoiding smelly foods and controlling the moisture, is there anything else we can do to prevent odors? Like, do those amazing enzymes have any role to play in odor control?
You know, they actually do. Some of those enzymes are specifically involved in breaking down the compounds that cause those unpleasant smells. It's like they're not just breaking down waste, they're also acting as little odor neutralizers.
Wow, they really are multi-talented.
Yeah.
So by creating a healthy and diverse microbial community, we're not only creating a more efficient composting system, but also a less smelly one.
Exactly. It's a win-win situation. And it really highlights how important it is to understand those microbial processes to get the most out of your vermicomposting experience.
I'm definitely starting to see that. Okay, so we've covered a lot of ground here. We've got the basics of vermicomposting down. We've met the microbial all-star team, and we've even tackled the odor issue. I'm feeling pretty good about this. Now I'm ready to get my hands dirty and actually start building my own composting bin.
Awesome. Let's do it. It's easier than you might think. First things first, you need a bin.
A bin? Like anything special or just I don't know, an old plastic tub?
Pretty much. Plastic tub works great. Just make sure to drill some holes in it for ventilation, so those little guys can breathe.
Right, give those worms some air. Makes sense. What about, what do you call it, the bedding?
Ah, the bedding. That's the worm's home sweet home. You want something nice and cozy for them. Shredded newspaper works well, cardboard too. Or coconut coir, if you're feeling fancy.
Coconut coir.
Yeah.
Okay, I've heard of that. So we've got our bin, our bedding. Now for the stars of the show, right? The worms.
You got it. But not just any worms, we're talking composting worms. Red wigglers are the most common.
Red wigglers. Okay. I think I've seen those at the garden center. So I've got my bin, my bedding, my red wigglers. Uh, what's next? Do I just dump them in and start throwing in my scraps?
Hold your horses. You want to give those little guys a little welcome snack first? Some fruit and veggie scraps are perfect. Just bury them under the bedding. We don't want fruit flies crashing the party.
Good point. Keep those fruit flies away. Okay, so we've got our bin all set up, bedding, hungry worms, a starter snack. Are we ready to launch this operation?
Almost. Remember, worms are a little picky about their environment. Keep the bin in a cool, shady spot. They like it between 55 and 77 degrees.
Okay, noted. Not too hot, not too cold. And I guess moisture is important too, right?
You bet. Keep that bedding moist like a wrung-out sponge. You can mist it with water every few days.
So temperature control, hydration, got it. Once they're all settled in, I can start adding my food scraps, right? Like on a regular basis?
Exactly. Just remember, don't overload the bin. It's a marathon, not a sprint. Those worms need time to do their thing.
Okay, I'll try to pace myself.
Oh.
But how will I know when, when the black gold is ready?
Well, it takes a few months for everything to break down. You'll know it's ready when it looks and feels like, well, rich soil. Dark, crumbly, very few recognizable scraps left.
Oh, I can't wait. And then I just sprinkle this magic soil onto my plants.
Pretty much. It's packed with nutrients, improves soil structure, helps retain water. Your plants will love it.
Wow, this is amazing. I'm so glad we did this deep dive. I'm feeling really inspired to start composting. I mean, it's good for the environment. It's good for my garden. It's almost like, well, it's almost like magic.
It kind of is. It's the magic of nature with a little help from those amazing worms and microbes we've been talking about. Speaking of microbes, there's actually another really interesting aspect of vermicomposting I wanted to touch on.
Another aspect. Okay, you've got my attention.
Well, it turns out that vermicomposting isn't just about creating fertilizer. It can also be used to, get this, clean up contaminated soil.
Wait, seriously? Like actually clean up polluted soil? How is that even possible?
I know, it sounds crazy, right? But it's true. Those worms and microbes, they're like little environmental cleanup crews. They can break down and detoxify all sorts of nasty stuff like heavy metals, pesticides, even some industrial pollutants.
So they're like what? Tiny little superheroes saving the soil from all those harmful substances?
You could say that. They're pretty incredible. And vermicomposting, it harnesses that power to actually remediate contaminated soil, make it safe for plants again.
That's amazing. But how does it actually work? Do the worms, like, eat the contaminants or something?
Well, it's a little more complex than that. When the worms ingest that contaminated soil, the contaminants pass through their gut.
Their gut. Okay, and what happens there?
That's where the magic happens. Remember that diverse community of microbes we talked about? Well, they're hanging on the worm's gut, ready to do their thing.
Right, the microbial cleanup crew.
Yeah.
So what do?
They have all sorts of mechanisms for dealing with those contaminants. Some of them can actually metabolize those contaminants, like use them as food.
Wait, so they're actually eating those pollutants? That's wild.
It is. Other microbes, they can transform those contaminants into less harmful forms, making them less toxic.
So it's like a microbial detoxification process.
You got it. And even the worms themselves, they contribute to the process. As they burrow through the soil, they create these little channels that improve aeration and drainage, creating a better environment for those contaminant-degrading microbes to do their work.
So they're like, what little engineers, optimizing the conditions for those microbial cleanup crews.
Exactly. And those worm castings, that rich compost they produce, that helps too. It improves soil health and fertility, which helps plants grow. And those plants can actually help extract and stabilize those contaminants.
Wow, it's like a whole chain reaction of goodness.
Yeah.
Nature really does have a way of healing itself with a little help from those worms and microbes.
It's pretty amazing, isn't it? And it shows how important it is to understand those natural processes so we can work with them, not against them.
Well, you've definitely opened my eyes to the incredible potential of vermicomposting. I mean, we started with turning kitchen scraps into fertilizer, and now we're talking about cleaning up polluted soil. This is mind-blowing.
I know, right? And it's all thanks to those amazing worms and microbes. Speaking of bigger picture stuff, we've been talking about backyard vermicomposting, but have you ever wondered if this could be done on a larger scale? Like industrial level?
Level. Hmm. I hadn't really thought about that.
Yeah,
But it makes sense, right? I mean, we generate so much waste as a society. We need all the sustainable solutions we can get.
exactly. And that's something that a lot of researchers and entrepreneurs are looking into right now. The potential is huge, but there are definitely challenges to overcome.
Like what?
Well, for one thing, space. We're talking about a lot more worms, a lot more waste, so those little backyard bins just won't cut it.
Right. We'd need some serious composting infrastructure, like worm skyscrapers.
Huh? Worm skyscrapers, I love it.
Huh.
But seriously, we need efficient systems that can handle those larger volumes of waste and create the right conditions for the worms and microbes to thrive.
And I guess transportation's a factor too, right? Getting all that waste to those composting facilities.
Absolutely. We need to make sure we're not creating more environmental problems by transporting all that waste around.
Mhm.
Sustainable transportation solutions are key.
Right. We don't want to offset all the good we're doing with the composting by, burning a bunch of fossil fuels to get it there.
Exactly. And then there's the public perception aspect. Not everyone is, shall we say, enthusiastic about the idea of being surrounded by millions of worms.
Yeah, the ick factor can be a challenge.
It can. So education and outreach are really important. We need to help people understand the benefits of vermicomposting, show them that it's not as scary or gross as they might think.
So it's about changing hearts and minds, one compost bin at a time.
You got it. It's about showing people that vermicomposting is not just about worms, it's about creating a more sustainable and resilient future for all of us.
Okay, so despite those challenges, it sounds like large-scale vermicomposting has a lot of potential. I mean, imagine diverting all that waste from landfills, reducing greenhouse gas emissions, and creating this valuable resource that can help us grow food and improve soil health.
It's a pretty inspiring vision, isn't it? And it's something that we can all be a part of, even in our own backyards.
Well, you've officially convinced me. I'm ready to join the vermicomposting revolution. I'm going to build my bin, start composting, and tell everyone I know about the wonders of worms and microbes.
That's fantastic. And remember, even if you don't have a backyard, you can still support vermicomposting initiatives in your community. Every little bit helps.
To all our listeners out there, we hope you've enjoyed this deep dive into the fascinating world of vermicomposting. It's a reminder that even the smallest creatures can play a big role in creating a healthier planet. Until next time, keep exploring, keep learning, and keep diving deep.
And don't forget to thank those amazing enzymes. It has to do with something we touched on earlier, those amazing enzymes. Remember how we talked about their roles in breaking down tough materials like cellulose and chitin? Well, it turns out that some of those enzymes have applications that go way beyond the compost bin.
Wait, really? Like what? I mean, I get that they're essential for composting, but what else can they do?
Well, take lipases, for example, those fat-busting enzymes. They're actually used in a whole bunch of industrial processes, everything from food production to biofuel synthesis, and cateinases, the ones that break down chitin. Researchers are looking into using them for things like wound healing, even cancer treatment.
Wow. So those tiny little enzymes that are busy working in my compost bin could also be helping to, like, cure diseases and create new technologies.
Exactly. It just goes to show how powerful and versatile the microbial world is. We're just scratching the surface of what they can do.
That's incredible. Okay, so I have another question about those microbial communities. We've talked about how they change throughout the composting process, but what actually drives those changes? What factors are at play?
That's a great question. It's actually a pretty complex interplay of factors. One of the biggest ones is the type of waste you're adding to the bin. Different materials will attract different types of microbes based on what they can break down. So if you're adding lots of yard waste, which is high in cellulose, you'll get a different set of microbes than if you're mostly adding food scraps.
So it's like you're catering to different microbial tastes depending on what's on the composting menu.
Exactly. And then you have the environmental conditions inside the bin, the
Mhm.
temperature, the moisture level, the amount of air circulation. All of those things influence which microbes thrive and which ones struggle.
So it's like creating the perfect microbe habitat, the ideal conditions for those little composting champions to do their work.
You got it. And don't forget about those earthworms. They play a crucial role in shaping those microbial communities too.
Right. The worms. We can't forget about them.
So how do the worms and the microbes influence each other? It seems like they're both essential to the process.
Absolutely, it's a real partnership. As those worms move through the compost, they're aerating the bin, creating more oxygen for those aerobic microbes that need it to survive. They're also grinding up the waste, which increases the surface area that those microbes can colonize.
So they're like little composting engineers optimizing the environment for those microbial communities.
Precisely. And as they digest the waste, they release nutrients and other compounds that can actually stimulate microbial activity.
Wow. So it's a real win-win situation. The worms help the microbes help the worms, and in the end, we get this amazing compost. It's a beautiful cycle.
It really is. And the more diverse that microbial community is, the more efficient the composting process will be. More diversity means a wider range of enzymes, which means they can break down a wider variety of materials. So it's all about promoting that microbial diversity.
Got it. Now, I want to shift gears a bit and talk about the environmental impact of all of this. We've talked about how vermicomposting reduces waste, which is great. But what about greenhouse gases? I mean, landfills are a major source of those harmful emissions, right? Does vermicomposting help with that?
It's a really important question, and the answer is a resounding yes. Landfills are notorious for releasing greenhouse gases, especially methane, which is really potent when it comes to trapping heat in the atmosphere.
So by composting our organic waste, we're keeping it out of those landfills and preventing those harmful emissions, right?
Exactly. And vermicomposting is actually even better than traditional composting when it comes to reducing greenhouse gas emissions.
Really? Why is that? I thought all composting was pretty much the same in terms of environmental benefits. Well, remember how we talked about those worms aerating the bin? That aeration creates a more favorable environment for those aerobic microbes, the ones that thrive in the presence of oxygen. And those aerobic microbes, they're much less likely to produce methane than the anaerobic microbes that thrive in oxygen-deprived environments like landfills.
So it's all about creating those oxygen-rich conditions.
You got it. And studies have shown that vermicomposting can reduce methane emissions by up to 90% compared to landfilling.
Wow, 90%. That's a huge difference. So not only are we creating this amazing fertilizer, but we're also making a real contribution to fighting climate change. I love it.
Me too. It's a great example of how something as simple as composting can have a ripple effect, creating positive change for both our gardens and the planet as a whole.
Well, I think you've officially turned me into a vermicomposting enthusiast. I can't wait to get started with my own bin and spread the word to everyone I know. This has been an incredible deep dive. I've learned so much, and I feel really inspired to put this knowledge into action.
That's fantastic to hear. And remember, even if you don't have a backyard, you can still support vermicomposting initiatives in your community. Every little bit makes a difference.
Absolutely. To all our listeners out there, we hope you've enjoyed this deep dive into the fascinating world of vermicomposting. It's a reminder that nature holds the solutions to many of the challenges we face, and sometimes the smallest creatures can have the biggest impact. Until next time, keep exploring, keep learning, and keep diving deep.
And don't forget to give a shout out to those amazing enzymes. They're the real heroes of the compost bin.